Yeah, so I'm sharing the slide. Yeah. Thank you very much for giving me this opportunity. I am Dr. Hanjabam Barun Sharma, sports and exercise medicine specialist and clinical and interventional physiologist, the president of Indian Society of Sports and Exercise Medicine. Let's begin the talk. So before going to the concept of this, sports nutrition, one has to understand sports and exercise medicine as a specialty. The ultimate aim is yes. And one has to understand, sports and exercise medicine, of science, the requirement like sports and sports exercise and human performance science. Another is the medical, clinical, and the allied health science, and the knowledge, competency, and the expertise of these two fields are required. And these are different subfield of sports and exercise medicine. And one of the subfield is performance enhancement by training, nutrition, psychology, and others. Scientific intervention and sports and exercise nutrition for health, fitness, and performance is very much an essential part of sports and exercise medicine. And one has to understand that there are two opposing concepts in sports and exercise nutrition. One is the classical, traditional high carb approach, another is low carb approach. And the low carb approach, sorry, is especially the keto adapted for keto adapted player or fat adapted player. And this is the carb dependent or high carb player, where in case of the high carb, carbohydrate is the form the base. Major chunk of the intake is carbohydrate. In case of the fat, high fat diet, it is the fat. Whether protein may be minimum or a high protein diet, it depends upon a type of the high fat diet. So these are the opposing view, and each has different different type of the evidences. There are pros and cons. So one has to as a sports and exercise medicine doctor or nutritionist, one has to understand what are the scientific basis of each high carb diet or low carb diet, and under what condition one has to use basic physiology. And the basic physiology is the muscle bioenergy. It is we all know that there are three systems. That is phosphagen system, which supply for up to say 15 second, anaerobic glycolytic system that is carb dependent up to 2 minutes. More than 2 minutes is the oxidative phosphorylation. It may be carbohydrate, it may be fat. The utilization. Like for example, you can see that 1 gram of carbohydrate, the energy, since energy produces 4.1 kilocalories, similar to protein, but fat it is 9.4. So fat has a more energy production for 1 gram as compared to carbohydrate. But the point is, the rate of the energy ATP production is much higher for carbohydrate as compared to fat. Like for fat, it is approximately 1.5 ATP per second, but for anaerobic, glycolysis for carbohydrate, it is 5 ATP per second. For oxidative carbohydrate, it is 2.5. So the rate of energy production of carbohydrate is higher as compared to fat. And also, if you see, the energy production based upon the oxygen requirement. The carbohydrate, the energy production by carbohydrate is more. Like for example, 1 liter of oxygen produce 5.05 kilocalorie with carbohydrate. With fat, it is only 4.69 for a molecule per molecule. The carbohydrate, the energy production is 6.3 as compared to 5.6 fat. So this thing one has to understand. So based upon this concept, it is always thought that for sprinting, for high intensity exercise, the carbohydrate is the foil source, the preferred foil as compared to fat. But the point is, the amount of the energy stored in the form of the glycogen is much less as compared to fat. So, like this is the amount of the fat, this is the amount of the muscle and liver glycogen. You can see that the muscle and liver glycogen they can provide a running of say 40 kilometer or 2 hour running. For fat, it is up to 4 days of running. That is 70,000 to 75,000 or more from fat in muscle as well as the fat cell. So this is the point. If your body is carrying so much of energy, why don't you use fat instead of carbohydrate? That is muscle and liver glycogen, which are very limited. So argument for high fat adaptation, high fat adaptation. But there is one problem for high fat adaptation is the crossover point, because as the exercise intensity increase, say more than say around 65, then the amount of the percentage of utilization from the fat is much less as compared to carbohydrate. That is, at the higher intensity of exercise, more than 60, more than 65, the the contribution from carbohydrate is much higher as compared to fat. That means if you want to do high intensity exercise, then your dependent on carbohydrate will be more as compared to as compared to fat. Similarly, if you see this diagram, you can see that this is the maximum fat or oxidation is approximately say zero point 0.2 to zero point 0.3 or up to zero point 0.6 gram per minute of uh, see that more than 85% of the VO2 max intensity, the contribution of the fat is nearly zero. That is, minimum contribution is there. This is the classic teaching. But you can see that lots of research has come up which says that the contribution from carbohydrate uh, 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 which was assumed to be 100%, when intensity is higher. It is not so. The contribution of fat is also higher. Lots of data has come up, and so this crossing point of the say up to say 65 or so has been challenged. It has been shown that this crossing point is it's increases. 5 or so in case of the high fat diet athlete, one has to understand. And also the assumption for higher contribution from carbohydrate in higher intensity may be because of the error in the data collection. Like for example, underestimation fat digestion can happen when the exercise intensity more than 70% of the high acidosis, hyperemia can happen, and more, and this will lead to high RER, and this RER can be misinterpreted as more utilization of the carbohydrate, because more RER means more carbohydrate utilization, less RER means more fat utilization. So erroneously, the fat utilization can be underestimated by using metabolic gas analyzer like method, gas analyzer method. So the contribution of fat may be higher. And this is especially true in case of the high carb diet athlete. This is the low carb diet athlete. The contribution from the fat is higher. You can see that the energy expenditure from fat is higher in case of the low carb, high fat athlete as compared, and different research has been published, and you can see that say in case of the low carb high fat diet, the crossover point can be up to higher, say more than 85 or 80% of VO2 max, and also the fat max can be higher. It is more than 1.5 gram per minute. The reported in the literature was up to 0.8 gram per minute for high carb athlete. We already we already see that the fat oxidation is minimum in case of the high intensity, but recent evidence has shown that even for more than 85% of VO2 max, the amount of contribution from the fat was found to be much higher. The peak fat oxidation was found to be around say 1.58 to plus minus 0.33 up to say 1.85 gram per minute. That means the amount of the fat oxidation, the rate of the fat oxidation, it's approximately to the similar level as in case of the carbohydrate. That means if the person is able to utilize this ideally, carbohydrate is utilized for high intensity exercise, but since from this data, it can be theoretically predict that such person can perform, high intensity or sprint type of exercise on fat also. This one has to understand. More data is it's a different paper which reported different fat oxidation level. Like for example, this paper by the Brook et al. They reported this high, fat oxidation approximately around 1.5 or so, and this is the again the rate of the oxidation and the carbohydrate oxidation, the fat oxidation. You can see that this is the pre and post. Yellow is the pre, this is the post, and you can see that after having a low carb diet, the amount of the carb oxidation, carbohydrate oxidation much lower, and the amount of the fat oxidation increases, and it is more than 1.5 or so. So after adapting to the high fat diet, your ability to oxidize fat at a very high rate will increase. This one has to understand. And this fat oxidation can take much long. It may be, say, minimum or 3 months or so. It may take up to 6 months also in some case. This one has to understand. And before the fat oxidation, many side effect can happen, many adverse effect can happen, including the decrease in performance. That's why fat adaptation should be done under a supervision. And this maximum fat oxidation can be more than 1.5 gram per minute, not per day, per minute. And hence, lots of different type of exercise, including high intensity. Sports nutrition book says that the high carb diet is the ideal for athlete. This we have already seen. Like for example, we already focus on replenishment of the glycogen. More glycogen means more endurance. This we have already heard, and based upon that, different recommendation are there. Like for example, low GI diet is given for glycemic index 15 to 45 minutes before the event. Otherwise, hypoglycemia can happen during the event. Enhancement for carbohydrate and protein should be given up to, say, 1 to 1.2 gram per kg per hour, up to 4 hours, or 5 to 7 gram per kg per day for moderate duration low intensity exercise. For extreme exercise of 4 to 6 hours per day, 10 to 12 plus gram per kg per day of the carbohydrate intake should be done. This is the protein intake. And for fat intake, less than 30% or less than 10% saturated fat. This is always described. But in case of the high carb, the high fat diet, then amount of the fat intake will be much higher, and this should be healthy fat. And they are more focusing on saturated fat, omega-3 fatty acid, and what do you call olive oil, and all that stuff, avoiding the omega 9 omega-6 fatty acid. They are also focusing on saturated fat. All these things one has to understand, and these are also the different the condition where carbohydrate is required. And also for sports drink also, 4 to 8% of the carbohydrate in the form of glucose polymer can be given, but dilutional hyponatremia can happen if excessive drinking is done. So these are the classic concept, and from where from the study which focus on importance of the muscle glycogen. Like for example, this is the classic study. You can see that, and this is the exercise duration. It's the muscle glycogen, and you can see that those who are having lower muscle glycogen, they are able to perform the exercise duration much shorter. That means having a higher blood glycogen level means a longer performance, and this was taken as evidence for necessity of the muscle glycogen for endurance event. But they have forgotten this blood glucose level, because you can see that those who are having low muscle glycogen, they also have their blood glucose also fall to the lower. So whether this exercise limitation is because of the lower muscle glycogen or lower blood glucose, one has to. So this blood glucose level may be a confounding factor which the author has neglected. And since the author has focused only on the muscle glycogen, they have concluded that the muscle glycogen is the linear relationship happens between the muscle glycogen and exercise duration, and hence having more muscle glycogen means more endurance. This was the conclusion which they have drawn. And similar here, you can see this is the carbohydrate loading, and because of the carbohydrate loading, this is the glycogen, and this is the mixed diet having mixed carbohydrate, and you can see that the mixed the performance of carb loading is higher as compared to the mixed diet. They are able to perform more quicker, and hence conclusion was given that muscle glycogen is important. finding, lots of strategy has been developed in order to improve the amount of the muscle glycogen, like in the form of the carb loading, in the form of the say, glycogen 12 gram per kg per day of the carbohydrate, 3 to 4 or 7 days of tapering, plus 70 to 80% of carbohydrate intake, mm, recovery 1.2 gram per kg per hour within the first 2 hours for increasing glycogen, or during the exercise, like for example 60 to 90 minute exercise, 30 to 60 gram per hour carbohydrate intake in the form of glucose polymer, or more than 2.5 hour of exercise, 6 to 60 to 90 gram per hour of glucose and fructose blend, all these things. So these are the different these are the different recommendation, whether it may be in the form 30 gram per hour, 60 gram per 90 gram per hour, depending upon the intensity and duration of exercise, or say in the form of say high intake, even 120 gram is also has been shown, not only 60 but up to 120 gram per hour of glucose oxidation is peak glucose oxidation is approximately around 60 to 100 gram per hour. And by adding 20 gram, because of different compensative different laws, they have different paper has shown that intake of 120 up to 120 gram per hour of glucose of rate or perceived exertion, or say lower muscle damage effect. All this thing has been shown, but the point is, why you using so much it has been shown to be linked with obesity or insulin resistance, or lots of metabolic abnormality, including the non-alcoholic fatty liver, PCOS, and diabetic, all this point. So one has to understand what is the ideal intake which has to be given. And for again, for recommendation are also there for a different ratio of the which type of the carbohydrate you have to take, like for example fructose and glucose, because if you keep on increasing the glucose, then the transport of the glucose in GIT will be saturated. So further increase in glycogen will not happen. And that's why fructose is useful. So table sugar is very useful. The ratio can be up to say 2:1 or 1.1 in case of the table sugar, or 0.8 to is to 1. So depending upon the duration of exercise, the ratio can be changed, and the total intake up to maybe up to 120 gram per hour. So all this thing is there. But as I have already focused, the utilization of the not much very high carbohydrate limitation is because of the hypoglycemia, then why to take lots of carbohydrate before the exercise, during the exercise? This one is more important. Different research has been done. This is one of the example. This is the blood glucose level. You can see the blood glucose level fall if you use the placebo, but if you use the glucose polymer, it keep on maintaining, and this is the carbohydrate oxidation. And you can see the muscle glycogen falls even in spite of the fact that you are taking glucose. But the point is, the glucose glycogen, the muscle glycogen remains the same here at this point. They are very low at this point, whether you take glucose or not. But prolonged exercise, even though you have the same muscle glycogen level, that means having the same muscle glycogen also, if you take glucose, then your performance can be increased, your fatigue will be delayed, and hence muscle glycogen is not so important. What is important is the maintenance of the plasma glucose level by intake of the glucose. And also you can see that the in spite of the fall in the glucose muscle glycogen, the ATP remains the same. That means the fall in the muscle glycogen does not affect the ATP, or it does not affect the TCA cycle intermediate. Lots of TCA cycle intermediate are there. They are not decreases. That means muscle glycogen is cycle. So muscle glycogen is not so important in the point here. And again, what about the carbohydrate loading? Here you can see this is a 4 kilometer, trial. and sprint, and this is the 1 kilometer sprint. You can see that this is the carbohydrate loading. This is the placebo where no carbohydrate loading is there, but you can see that 4 kilometer or and 1 kilometer also every performance is relatively same. Power output also same, time also same. That means there is not much so beneficial effect of carb loading. Carb loading has not so beneficial effect if you take loading based upon this paper. One has to understand. So this also again shows the importance of the blood glucose level, not the liver, muscle glycogen. And liver glycogen, however, is important because liver glycogen is directly responsible for the blood glucose level. This one has to understand, not the muscle glycogen. So this is the point. During the exercise, your muscle glycogen will keep on falling, and ATP is this is the ATP required for the exercise, and this ATP has to be provided by other means because muscle glycogen is keep on falling. Other means whether it for maybe muscle triglyceride or blood-borne a substance like free fatty acid, glucose, lactate, or ketone. And if your maximum, saturation is reached for ATP production, then ATP deficit will happen. If ATP deficit happens, then what will happen? Your muscle will go into the rigor because ATP is required for muscle relaxation also, but it doesn't happen during the normal process. Why this is so? Because your body, your CNS, your central nervous system sense that there may be deficit of ATP before the ATP deficit happens. They reduce the requirement for ATP. And how reduce the requirement of ATP can happen? By just preventing the exercise to happen. That means in order to protect the body homeostasis, motor recruitment during the exercising limb is progressively reduced in anticipation. And this is known as a central governance theory. That's why this your CNS is very important. Before having to exercise. So this is the concept, and why how this is important, because this can be seen in the form of the increase rating of perceived exertion. You can see that this is linearly related with exercise timing. And in spite whether you have a high glycogen or low glycogen doesn't matter. After a time, your rating of perception is very high at around 18.1. You will stop the exercise because of the very high fatigue level in spite of the having high muscle glycogen. And here you can see that as you keep on doing the exercise, will be decreases, and hence and also your IEMG will also decrease. That means recruitment pattern from CNS will also decreases. That means your CNS is preventing that exercise. Otherwise catastrophic result can happen. This again can be seen from this example where you can see that this is the placebo trial where no carbohydrate is intake, and hence the blood glucose level, arterial blood glucose level keep on falling. This is the blood glucose level is maintained, and here this is the rating of perceived exertion, and you can see that this around 120, this rating of perceived exertion increase like anything. And why this is increased after 120? This is the answer lies here. And this is the cerebral blood glucose monitoring, where you can see that the intake of glucose intake by your brain, and you can see that the in glucose intake by your brain falls significantly after 120, because of the low blood glucose level, your brain is not able to utilize the glucose, and hence the glucose utilized suddenly fall after 120, and this causes sudden rise in fatigue level, and you are not able to do the exercise. And that's why your maintenance of the blood glucose level is very important, so that your brain is able to utilize the glucose. But again, one point is here: if your brain is able to utilize ketone body sufficiently or fat sufficiently in case of the fat adapted athlete, then fatigue can also be reduced. That's why fat adaptation is another important. This is the concept of the central governance theory, where this is the different part of the hypothalamus, like it may be area postrema, arcuate nucleus, basolateral medulla, dorsomedial nucleus, dorsal motor nucleus of vagus, lateral hypothalamus, nucleus of textus solitarius, everything. So all these things are this area. They sense the availability of the fuel or glucose, and based upon, and they also modulate, depending upon your sympathetic or parasympathetic and other hormone body, your CNS, that this central governance can decrease and limit it will prevent prevention of the hypoglycemia, will prolong the exercise. And liver glycogen is important because liver glycogen can directly lead to directly affect the blood glucose level, and oxidation of the fat oxide, increasing fat oxide and dependence on other fuel other than the glucose can can help prevent the fatigue. So when carbohydrate is not ingested during the exercise, then in order to minimize the glucose oxidation, then your exercise will be limited by your central govern your CNS in order to prevent the potentially fatal hypoglycemia. Otherwise, the brain damage can happen because of the collapse. The brain will reduce the insulin. Brain will restrain the amount of the work done by for exercise, and hence one has to work for psychological training also, not only nutrition. And here also you can see that these are different type of the combination of the player. Like for this is the high glycogen plus carbohydrate intake during the exercise. This is the high glycogen without carbohydrate intake. Low glycogen. Low glycogen means the person who is following the low carb diet with glucose intake. You can see that whether the person is following the low carb, that doesn't matter. If you keep on drinking the glucose, then and the person who is having the low carb diet without any intake will have the lowest blood glucose level. This is the orange one. So that means, for athlete who are uh, during the exercise, doesn't matter whether you follow high carb diet or low carb diet. At least from this example, we can see. And also here, the point which one has to understand, in case of the 70 kg person, only 1 teaspoon of the, sugar is present in your blood. There is approximately 4 to 5 gram. This one has to understand. And the oxidation of the glucose can be up to say 2 gram. That is, 120 gram per hour of the glucose. Glucose and the muscle uptake of the glucose can be 5 times as compared to resting. And also glucose production by the liver can be up to say 10 times during the exercise, high intensity exercise. So all this thing one has to is a minimum amount of the glucose intake during the exercise has to be done in order to prevent the hypoglycemia. But how much intake is required? This is another graph. You can see this is the performance. This is the glucose intake during the exercise. There is no relationship. See, haphazard dot is there. No pattern is there. That means a minimum, a small amount of carbohydrate intake just to prevent the hypoglycemia or just to prevent the fall in blood glucose, below the baseline level. This one has to understand. It is approximately how much? Approximately say 20 to 25 gram per hour, depending upon the requirement. So this one has to understand. And therefore, fat adaptation. If you are able to use fat, if you are able to if your brain is able to utilize ketone bodies, if your muscle is able to utilize fat, then and since you are carrying more energy in the form of fat, your success of endurance lies on that utilizing of fat. The success of the endurance, the store fat could fuel running for nearly 4 days, but muscle glycogen only for less than 2 hours. The secret of the endurance lies in unlocking the potential to use fat and hence becoming fat adapted. This one has to understand. Because maximum utilized can be more than 1.5 gram per minute, and hence lots of different exercise can be done, including the high intensity theoretically. So that's why what is the possibility? There are lots of randomized control trial have been done till 2022 February. They said by high fat diet, also low carb diet also. Recovery time is given if sufficient adaptation time is given, and the person is able to adapt to any kind of either diet, whether it is high carb diet, low carb diet, doesn't matter, because exceptional physiological adaptability of human body is very very high. And high carb diet may not be necessary, may not be necessary for performance improvement. Some athlete may not improve their performance by following the high carb diet also. Has been shown to be related with, say, non-alcoholic fatty liver or type diabetic, or say high what do you call insulin resistance. Yeah, all these things personalize a plan of the glucose, especially during the exercise, by using continuous glucose monitoring is important. And nutrition is just one component of this performance. Performance is a multifactorial in nature, and therefore only focusing on nutrition is not the answer. You have to focus on everything. At least individualization of the nutrition one has to be done. It can be periodization also. Sometimes high carb diet may be required, not very high, but relatively high carb diet, especially for heavy training, during the heavy training, or in order to prevent, say, REDS, that is relative energy deficiency in sports. But amount of the carbohydrate required during the exercise may be much smaller, just to prevent the hypoglycemia, just to prevent the fall of blood glucose below the baseline. This one has to, and fat adaptation has to be done always under the supervision, and chrono nutrition has to be taken care of. That means your nutrition has to be based upon your circadian rhythm. And exercise induced hypoglycemia, EIH, is the major limiting factor, and hence muscle glycogen is more important as compared to the liver glycogen is more important. Sorry, liver glycogen is more important as compared to the muscle glycogen. And focus should be given on liver glycogen, and especially on the level. And you have to open your mind to the latest research and ready to accept the change. If it is going against your and dare to think and experiment beyond the conventional high carb diet. So personalized nutrition, because positive activity, exercise, and a lifestyle will lead to positive physiological adaptation. This one has to understand. And high carb diet, following only high carb diet, following with high carb diet, processed food, especially high omega 6 fatty acid fat, unhealthy fat. All this lead to insulin resistance, which are responsible for lots of non-communicable. In order to maintain your health and fitness, not only performance, your goal should be for performance improvement as well as for long-term health. This one has to understand, and focus has to be given on personalized and unlocking that huge amount of energy stored in the form of the fat. Thank you very much.